Hi, my name is Raj Joshi. I'm a physics teacher from South London, and in this session I want to go through all the specialist terms that we use and the equations and definitions for them in electricity. You might want to pause the video here to jot down this table so that you can keep a note of all the terms that we use. The first phrase that we typically use is potential difference, or sometimes we call it voltage, although potential difference is the proper formal way of talking about it. And essentially what this is this measures the amount of energy per unit charge between 2 points in a circuit. So it's the amount of energy per charge, how much energy each load of electrons carries. And it's called potential difference because it's looking at the difference in electrical potential energy, and a difference because it's looking at from one point to another point. That's the reason why a voltmeter, to measure this, needs to take 2 points. So it looks on one side of the component and the other side of the component, looks at the change in energy per unit charge, and works it out. It's measured in volts, and that's named after Alessandro Volta, so it's a capital V. You can think about the current in an electrical circuit being very similar to the current in a stream or a river, for example. It's the rate of flow of the charge going around the circuit. It's measured using an ammeter, and you think about an ammeter as being a bit like a traffic camera or something like that, where it's looking at the charge, it's looking at its watch and saying, okay, right, we've got so many electrons going through in a certain amount of time. So current is the amount of charge that's going past a particular point in the circuit in a certain amount of time. Again, it's named after a person, it's named after ampere, so we call it an amp, and we use a capital A to represent that. A weird thing about current is that we use the letter I to represent it in equations, and that's because current used to be called electrical intensity, how much charge, the intensity of charge flowing through that point in a certain amount of time. Charge itself is a bit more difficult to define. We can think about it as some kind of innate property of things like electrons and protons. We know electrons have a negative charge, protons have a positive charge, and so on and so forth. At A level, we would talk about it being a measure of how much something is affected by an electrical field. But at GCSE, it's probably best just to leave it as a kind of hand-wavy definition as the quantity of electrons. If you've got more electrons, you've got a larger amount of charge. It's measured in coulombs, where coulombs is a huge amount of electrons, 6 times 10 to the 18, so that's 6 with 18 zeros after it, electrons. So charge is just the amount of electrons that you've got in a particular place. They could be staying still, a buildup of charge, a static charge, or they could be current electrons, they could be flowing around. Resistance is essentially a measure of how difficult it is for a current to flow through a particular component. So obviously resistors have a resistance, but all other components do as well. So light bulbs, motors, even just the wires that we use in an electrical circuit have a resistance. Although in the case of wires, it tends to be a tiny, tiny amount, an amount that we tend to just ignore. So we use a symbol R to represent resistance, and we use an omega sign, a Greek letter, as the unit. Now this is called the ohm, and that's the same ohm that we think about with Ohm's law. So Ohm's law, V equals IR. We can rearrange that to say R is V divided by I to work out what the resistance is. Power we can define in more than one way. When you were studying mechanics, you might have been introduced to power as the rate of energy over time, or how quickly energy is being transferred from one way to another. And that's a really good way of defining it. In electricity, we can also define it as the current times the voltage. Power is measured in watts. And if your teacher thinks that they're incredibly hilarious, they might ask you, what is the unit of power, and then have some kind of joke where they say, well, that's a watt. What is the unit of power? Watt. Our final quantity that we need to know about is time, and we use a lowercase t for that. An uppercase T would be for temperature. And time is just the duration of something. We always use seconds to measure the amount of time in a physics equation. So an exam question might give you an amount of time in minutes, and to transfer that into seconds, you just need to multiply whatever quantity by 60. So if it's 1 minute, it's 60 seconds. If it's 2 minutes, it's 120, and so on and so forth. So that's a common thing that people trip up on. Always turn your time measurement into seconds. I hope that defined a few of those terms for you. I've put all of those terms into this table here, so if you need to pause the video, you can copy it down. You'll need to know the definitions of potential difference and current, and that's quite a nice, easy recall answer that you may need to do. Those equations that you'd need to use will come up quite a lot. You don't quite need to know how many electrons in a coulomb of charge, just you need to know it's quite a large number. I hope that's been useful for you. Again, if you need to copy these down, pause the video and you can type them down.